Hello student, I am Sudha Rani Dehri. Today I am going to introduce a very interesting topic to you, complex numbers. But before coming to the definition of complex numbers, let us recall what are real numbers. Integers, rationals and irrationals all together are called real numbers. Now try to remember what are integers. All positive number like 1, 2, 3 up to infinity with 0, and negative numbers like -1, -2, -3 up to -infinity are called integers. Rational numbers are of the form p by q, where p and q are integers. Numbers which are not rationals are called irrationals. Now let us come to the definition of complex numbers. Numbers of the form a plus ib are called complex numbers, where a and b are real numbers. Now you must be thinking, if we are taking sum of two numbers, then why we are giving it a different name? Here just look, in a plus ib form I said that a and b are real numbers, but I did not say anything about I. In fact, I can say that I cannot be real, and if I cannot be real, so their sum cannot be defined, and that's why we cannot say that a plus ib will be a real number, and so we gave it a different name, complex numbers. Now obviously your question will be, if I is not a real number, then what is I here? Here I is nothing but the value of square root of -1, and I is called an imaginary unit. Now you may think, okay, we understood that I is the square root of -1, but how can we say that I cannot be real? Up till now you must have noticed that we have always found square roots of positive numbers only. For example, we have found square root of 2, which is 1.414, which is a real number, and square root of 4 is 2, which is an integer. But can you find a real number which will be the value of square root of -1? This question might be confusing for you. So let me transform this question. Since I is equal to square root of -1, so if we take square on both the sides, then it becomes I square is equal to -1. Now the same question can be asked as, can I find a real number whose square will be a negative number? Obviously not. You must have seen that square of a real number is always a positive number. If we take square of a positive real number, it will be a positive number, and if we take square of a negative real number, then also it is a positive number. For example, you can see square of 2 is 4, and again if we take square of -2, then it's again 4. It means in case of real number, if we take square of real numbers, either it is positive or negative, we always get a positive number. And since we cannot find a real number whose square will be a negative number like -1, therefore we can say that I can never be a real number. Now let's see, I said that I is the value of square root of -1. Then you can think, what will be the value of square root of -2 and square root of -3 and so on? Just have a look. Square root of -2 can be written as square root of product of -1 with 2, which can further be written as product of square root of -1 with square root of 2. Now if we substitute the value of square root of -1, then it can further be written as I times square root of 2. Similarly, we can see that square root of -3 can be written as square root of product of -1 with 3, which can further be written like this, and it gives us value I times square root of 3. And so Generalizing this, we can say that in general, for any positive integer a, square root of minus a will be nothing but I times square root of a. Now let us come to the powers of I. Up till here we saw that value of I square was minus 1. Now we will increase the power of I and we will find the values of powers of I. So let's first see I to the power 3. Since I to the power 3 can be written as product of I square with I, now I can substitute this value here, which will give me product of minus 1 with I and which gives us minus I. It means that value of I to the power 3 is minus I. Again, I to the power 4 can be written in terms of I square and which gives us value 1. Similarly, we can find the value of I5, which is I, value of I6, which is minus 1, value of I7, which is minus I, and so on. And therefore, I8 can be written as square of I to the power 4, which gives us value 1. Here we can notice one thing. The value of I square was minus 1, value of I cube was minus I, value of I to the power 4 was 1, value of I to the power 5 was I. Now, if we increase the power by 1, for example, if we increase the power 5 by 1, we get power 6 and then the value of I to the power 6 is minus I, which is same as the first value. Again, if we increase the power 6 by 1, we have power 7 and the value of I to the power 7 is minus I, which is same as second value. And so on, value of I8 is 1, which is same as third value. Value of I to the power 9 is I, which is same as fourth value. It means if we increase the power by 1, then the value get repeated. Now let us see what will be the values of powers of I for negative powers. For example, if I take power as minus 1, then I to the power minus 1 can be written as 1 upon I. It can further be written as product of 1 upon I with 1. Now, 1 can further be written as I upon I. So, we replace 1 with I upon I, which gives us I upon I square, and substituting the value of I square, we get I upon minus 1, which finally gives minus I. It means that value of I to the power minus 1 is minus I. Similarly, for power minus 2, I to the power minus 2 can be written as square of I to the power minus 1, and substituting the value of I to the power minus 1, we finally get I to the power minus 2 is equal to minus 1. Again, we can find the value of I to the power minus 3, which is nothing but I to the power minus 4, which is 1, and so on. And proceeding this way, we can see that value of I to the power minus 8 is 1. Again, we can notice here one thing, that value of I to the power minus 1 was minus I to the power minus 2 was minus 1, I to the power minus 3 was I to the power minus 4 was 1. Now, if we decrease the power minus 4 by 1, then power becomes minus 5 and the value of I to the power minus 5 is minus I, which is same as the first value. Again, if we decrease the power minus 5 by 1, then the power becomes minus 6 and the value of I to the power minus 6 is minus 1, which is same as second value. And similarly, value of I to the power minus 7 is I, which is same as third value, and I to the power minus 8 is 1, which is same as fourth value. It means that for negative powers, if we decrease the power by 1, then all these four values get repeated. One more thing we can notice here, that value of I to the power 4, I to the power minus 4, I to the power 8 and I to the power minus 8 is 1. So, generalizing all these, I can say that in general, if k is an integer, any integer, I'm not differentiating it whether it is positive or negative. If k is any integer, then value of I to the power 4k will be 1, and so value of I to the power 4k plus 1 will be I, value of I to the power 4k plus 2 will be minus 1, and value of I to the power 4k plus 3 will be minus I. Now, using all these powers of I, if I ask you to find the value of the product of minus 1 by 5 I with square of 2 by 3 I and I5, then what will be your answer? Since this term square of 2 upon 3 I can be further written as product of 2 square upon 3 square with I square. So now this whole product become product of minus 1 by 5 I with 2 square upon 3 square I square and I to the power 5. Now, for solving these kind of product, to get value of these kind of product, what we do? We take all the numbers before I and the powers of I together and we multiply them, and we take all the powers of I together and we multiply them. You can see that minus 1 by 5 was number with I, so I took minus 1 by 5. 2 square upon 3 square was number with I square, so I took 2 square upon 3 square, and there in the question only I5 was given, so I assume that its number is 1. And here you can see that in the question there was I, no power on I was given, so I can assume that the power of I is 1, and I took I square and I5 and I am taking their multiplications. Now this can further be written as minus 1 by 5, and 2 square upon 3 square can be written as 4 by 9 and 1, and we will take their multiplication. Now since the base are same, we will add on the powers, and so here the term become I to the power 1 plus 2 plus 5. Now if we multiply all the numbers, we can see that the result will be minus 4 upon 45, and if we add the powers, we get I to the power 8. Now we know that value of I to the power 8 is 1, so here we will substitute the value of I to the power 8, and so this can further be written as product of minus 4 by 45 with 1, which gives us the value minus 4 upon 45. Find the value of the product of cube of 2I to the power minus 1 with 1 upon 4I and 5I to the power 5 and I to the power minus 7. In today's lecture, we define complex numbers as numbers of the form a plus ib, where I was the value of square root of minus 1 and a and b were real numbers. We also saw that for any positive integer a, the square root of minus a was I times square root of a. We also calculated the powers of I, and so we arrived at the conclusion that for an integer k, the value of I to the power 4k was 1, the value of I to the power 4k plus 1 was I, the value of I to the power 4k plus 2 was minus 1, and the value of I to the power 4k plus 3 was minus I. In next lecture, we will see some examples of complex numbers. We will also define what are real and imaginary parts of complex numbers, as well as we will calculate modulus, conjugate and multiplicative inverse of complex numbers. Till then, take care.